Okay, so we're given a converging meniscus lens with a refractive index of 1.5. It has a concave surface with radius minus 20 centimeters and a convex surface radius of 12 centimeters, and we're asked for the focal length. So just to be clear what we're talking about, let's draw a cartoon of the lens. The lens has a concave surface, radius of minus 20. So there's the concave surface, and there's a radius of curvature of 20 centimeters, and it's minus because the sign convention is that concave surfaces on lenses have negative radii of curvature, and a convex surface whose radius is 12 centimeters. So 12 centimeters will be much closer than the 20. So 12 centimeters. That's a parody, but not a bad parody, that this radius is 12 centimeters, and it's positive because the surface is convex. So there is the lens, and the bit I'm hatching is the glass, which has a refractive index of 1.5. So except for understanding that we need to use a negative radius, this is a case of substitution. We need the lens maker's equation. 1 over the focal length is equal to n minus 1 multiplied by 1 over r1 plus 1 over r2. Okay, so substituting in values, we have is equal to 1.5 minus 1 is 0.5, which I'm simply going to write as a half. And we have 1 over minus 20 plus 1 over 12. And if I prefer to have my negative signs on the top of fractions, therefore I'm going to multiply the first fraction by minus in top and bottom, which converts the sign on the bottom to a plus. So it's minus 1 over 20 plus 1 over 12. Okay, so the simplest way to do this calculation is simply to do it. So we have 1 over f equals a half times minus 1 over 20 is minus 0.05 plus 1 over 12 is 0.0833 recurring. So 0.0833 recurring minus 0.05 times half, and then we find that 1 over f equals 0.0166 recurring, and therefore multiplying both sides by f, that becomes 1, and dividing both sides by 0.0166, that becomes 1, and here on this side I have 1 over 0.01666. So 0.01666 reciprocal tells me that the focal length f is equal to 60.0 centimeters. And I have been a little naughty and sloppy in this calculation because I should have put the units of centimeters in when I substituted for R1 and R2, and then this would have been in units of reciprocal centimeters, and therefore F is in units of centimeters. So if I'd done the units correctly, this is the answer that I would have got. And as always, help the person marking the question to find your final answer. So with a calculation of this level of complexity, my suggestion would always be that once you think you have the answer, you actually substitute back into the original equation and make sure that the two sides are equal to one another. And if you do that, you will find that we have not made a mistake. And we're done.